Hello, everyone. I'm Adrian. I'm working for Viant. I'm leading their AdCloud runtime team. And we kind of unique in terms of like scale and volume. We're like daily handling around 40 billion requests daily, which is rather large scale. And for us, like, quality and low latency is like super important thing. And over course of the years, we've developed obviously very strong end-to-end testing tools, also in Go, and this is what I'll be sharing with you guys today. So let's start with basic. Okay, I'll do. So let's start with the basic. Okay, so what is the end-to-end testing? It is nothing else than methodology that tests entirely system in a kind of almost like production environment with all interaction, network interaction, database, and other components. Like with all the testing, we verify desired output for specified input. However, in the end-to-end testing, we do it in the context of business flow and business feature. Also, I would say the end-to-end testing is very much a game of the tracking all the possible inputs, various different components, various user action, and also tracking those outputs and making sure that we cover everything pretty much. Okay. So we know we've got various applications. We've got ETL application, we've got UI, we've got web services. And as I said, this is the game of the input and output. So, so we need to answer a few basic questions. What is the typical input, for instance, for ETL application? So let's say it. So we've got some data, structured data, either in database or data store. We may have some logs as an input that our ETL process will take. We may have some transformation rule or configuration and settings, and our output will be, again, transform data either in database on some structured file or application logs. So I'm just calling this out because those things will be very important for us to consider, especially when we will take on the end-to-end testing. So how about web services? So what do you think? What's the typical input for web services? Yeah? HTTP request with all the headers, body. Obviously, setting and configuration, this is pretty much universal for the application. Maybe some business rules, application is data-driven. And output, HTTP response, some business transaction, application log, maybe updated data in database. How about UI application? What would be the input for UI? Yeah? User interface with user interaction, clicks, touch, typing, and again, setting configurations, nothing new. User metadata from database, data store. And then output will be updated user interface, maybe again, some performance data, transaction logs, maybe some other metadata. So these things will be very important for us, again, to look comprehensively to end-to-end testing input and output. In this presentation, I will be heavily relying on Endly. And Endly is the open source framework written in Go for end-to-end testing. It is engineer-centric, it is extendable, it is flexible, and it's language agnostic, which means you can write tests for Go, but you can write actually end-to-end tests for any language. As a matter of fact, you not write any code for it. You just provide, the declaration. You play a lot with input-output data, and you use kind of declarative approach here, which I will be showing during the course of this presentation. So, declarative versus imperative, right? So, what's the really main difference? We know how we can code something. So, on the left side, there is an example of achieving task, the copying, let's say, certain asset from, let's say, S3 to Google storage. So if I use the declarative approach, I just provide the simple instruction. This is my source, S3, this credential, and this is my destination, move this data for me. So this is declaration, right? If I were to use imperative approach, then I will have to code pretty much the same thing, step by step, providing instruction, and then using various API to achieve this task, right? When I'm using declarative approach, I really don't care about what the API implementation is. I know once I provide that definition, that the job will be done. I believe that will be very helpful for us to actually, look at the end to testing some maybe simple application. And I've prepared for the sake of for this presentation, the single sign-on application that you can find also with the Endly as one of the many examples how to test various kind of application. This application is very simple. It has the front end, back end. It has IP lookup service, which give information about incoming IP, because that application wants to only allow the registration for user that coming from US, as an example. And also, this application has Aerospike as a backing database. No, it's some caching layer, right? And interactive maze servers. So this is our application. So let me now show you a quick demo. What does it mean end-to-end testing with Endly? Test used by the application. Simple sign-on application implements two basic operations: sign up and sign in. Before we can get to actual testing, the system used by the application with all required services has to be prepared. On top of that, the app itself also needs to be deployed. Our users then need a test runner. I will start with the init task. The init task will do the following. We will get Aerospike and Cache instance up and running. We will start IP lookup service, and finally, we will build and deploy applications in the standalone mode. Once everything is completed, I should be able to see that my both Aerospike and Cache instance up and running. And if we go to browser and check that services up and running, and also I should be able to check where the application is used. Sign up. Introduce my sign in. Great. At this point, I can start actual testing. I'm using pretty nice test now, and I will run but some use cases also use HTTP runner specifically for testing AWS sign-up rejection use case where it's always I believe maybe we just keep this demo. If anyone is interested, you can Google on YouTube Endly SSO UI demo, and you can just watch it on your own kind of pace. Definitely the context, meaning this presentation, otherwise it may be kind of confusing. But let me continue then. So the idea is, to show you quickly, the end-to-end testing tool that enables you to automate all the tasks, but at the same time allows you to be very, very selective and just focus on one thing at a time. So this is really important when we want to get everything automated from our system preparation, application being built and deployed, and want to focus on individual cases. So, yeah. Okay. So in this particular SSO application, we've got two main system flow that we want to test. The first one is the registration flow. And there's a lot of use cases we can think of. The very first one is empty field use case. We've got invalid email use case, password doesn't match use case. Email has been already registered. User IP is coming from whitelisted and blacklisted geolocation. And finally, you want to test that user has been successfully registered. And then finally, you want to test sending user activation and email verification. So there's so many cases just for this one, simple register user process flow, and very similar way of thinking. We may apply some other cases for simple login process flow. The first one, empty credential use case, login with not an existing user case, invalid credential user case, and sign invalid user finally. So in order to do end-to-end testing, which is the engineering-centric, which means that when we're building application, we want to simplify our life. We have to first get environment prepared for the application. Remember, we're imitating production. So if our application uses the geo lookup service, we need the geo lookup service running on our box. If it uses Aerospike or any other database, we want to also have it on, in our hands. So the next important thing is that, our application will deal with one or multiple data stores. We want to make sure that not only those database instances up and running, but also they already have the database and maybe some initial data, static data, just sitting there for our application to get and use it. Finally, we want to make sure that our application is built and deployed, because we don't do this manually thing. And once we've got those three first workflow ready, then we want to run our test plan. And the test plan will be actually responsible for setting initial application state and just running various test use cases that we've prepared for application. So here is an example with Endly how system workflow may look for this application. So this particular application, as I called out before, uses the Aerospike as a database and uses the memcache service and also uses the IP lookup service. The first two services can be easily implemented with the Docker. The third one uses like a mocking endpoint that first you record your interaction with actual lookup service, and this particular component allows you to kind of replay depending what's incoming request is. It matches with the original recorded traffic and then just replay it. But this actually prepares you that system for your application to start playing. So the next important workflow is the data store workflow. In this particular case, this example for the MySQL, important thing is this, that I have the schema in the top script thing, which actually loads my database. And at the very bottom, I want to populate with some static dictionary data. Finally, I've got the application workflow, which will be responsible for build and deployment. There's no one unified way of the building and deploying application. So we've been building various mechanisms so you can take advantage of the Docker Compose and Dockerfile. You can use the SSH command to kind of instruct how do you want to build the application yourself, and this is a kind of example of one of these workflow. You can just build your own workflow that you can reuse across your way of building application across the company. So let's look about regression workflow. So in the regression workflow, we want to make sure that we can run multiple time regression workflow on its own. So in this particular step, you also want to make sure that we set initial application state. If our application produces log and we want to actually validate them, we need to set some log listeners, especially if there's log rotation or compression or any other these mechanism. At this particular regression workflow, you may also place tasks that will be responsible for the starting application. And finally, once you've got all these tasks ready, you want to actually execute your test plan, which, again, you may have very initial data per each use cases. Then you run various runners. It could be HTTP runner, Selenium runner, REST runner. It could be some SSH command. It could be some other workflow that run various steps just to trigger application to work, which would be, for instance, launching data flow or data proc, or if it's ETL application, really depending on the use cases. And finally, you want to verify your output. And then if you can do verification per use cases, sometimes it's also important to do verification in bulk once all the use cases are completed. Like, especially if your application writes something asynchronously, you don't possibly spend time and wait till something is produced. It's better to queue this up and then just do bulk validation towards the end. So there's an example how you can set initial application state. And when we setting initial application state, we may really deal with various cases and various databases. Now, well, typical example is database that has support for auto increment or sequences, right? There's another data store that you want to handle is like key value store. In this case, you want to auto generate numbers. And sometimes you want to provide that number and be static. The constant prompt for various scenarios, there's no one unified way, but it's important to have ability to do all this kind. And let's focus about this initial use case in terms of like user. So imagine this case that I want to test case that user has been already registered, right? Which means I need to, before that the use case actually runs, I need to register user in data store. So when the times comes in for me to provide that user in UI, already I have error that has been registered, but this happens as a part of the testing setup. So you may do various, you may address this particular setup in various ways. You can either provide just email as a kind of primary key to your database. You may use the database that supports the sequences, and you may use the code like this. Or for the key value store, you can auto-generate your user ID. So all these various options are already supported and nicely work with the either SQL or NoSQL databases. So regression testing. So as I said, you can use various runners for the testing. You can use Selenium. This example of the Selenium instruction, where in the comments you just provide instruction what to do step by step, and then in the expect you just provide what do you expect once this instruction been completed by Selenium. Here is an example of the REST runner. You just provide your data payload, and then you provide what you expect back. And here is an example of HTTP runner. You can be so much more complex. This particular case just checks status response code. Another important thing is data organization. Especially when you're growing the end-to-end testing, you end up with hundreds of the tests per year easily. So it is critical to have the whole story in one place. When I meant one story, I meant all the input data, all the expected output and also instruction how to test something. So Endly uses this kind of folder organization to provide all the to store all information in one place. So it's really easy to understand if something goes wrong, to troubleshoot, change, extend. Okay. So you've already seen, some YAML file, some JSON file, and you possibly think, oh my gosh, again YAML against those files. Why do we need to do that? Well, the truth is this, that it's really difficult to start something from scratch. Even if we just talking about these 4 workflow like system, data store, application, and regression, it still will take you a good amount of time if you have to build it from scratch, right? So what we end up doing is we just prepared the workflow end-to-end test project generator. So in this test project generator, you can use various options. You can either provide the URL for your application that you want to test it, and then you can decide what database that application uses, and you can provide various scenarios for loading data, verification, either data in database or logs. And you can also provide various runner options from Selenium, HTTP, REST, SSH comments, and even more complex workflow as a part of the individual use cases. So this provides a great simplification and a very nice place to start with. Let me move on. And I think I will skip demo. I had demo for the generator, but I don't believe the audio works, and it's worth wasting that time. So let me move on. So let's talk about the real world, right? So one of the important things is that in order even to set up basic use case, like in my case, we're dealing with the real-time selling, real-time buying. You have to prepare, like you need to populate data at least like, I don't know, in minimum 20 tables just to prepare one use case. But this is just from the metadata. Then also, if your use case touches, site profile or user profile, IP profile, they need to also prepare those. So that maybe feel overkilling. So what we did, we came up with this idea of virtual mapping. Imagine a view, right? View is a nice thing, abstraction that you can query and then join multiple tables underneath. So imagine the other way around, that you've got this virtual mapping that presence of the field or column triggers routing to one of multiple tables at the same time. So technically, you can still provide one file with various columns, and just presence of this column will automatically trigger insert or update to various tables underneath based on the definition for the mapping. So this is like huge simplification, because in this case, you're not dealing anymore with 12, 20, 30 tables, but you're just dealing with one table that you're operating maybe 20, 30 columns. Another thing is a lot of applications have like very sensible, reasonable defaults, which means that, guess what? In most of the cases, you don't need to even set it up. So in your mapping, you can also specify the default value. So if you don't explicitly specify them, they will be used as you provided in the mapping. Okay, another use case. In our particular case, we're dealing with real-time selling, real-time buying, and different exchanges have different formats. Most of them use the JSON, but there are some that use the protobuffer and other binary formats. From engineering perspective, we don't really deal with this thing, right? We want to have this kind of ability to see really what is that binary representation and only work on that representation that is human readable, right? So in our HTTP runner, you've got option to provide dynamically UDFs, and in this example, you've got request UDF and response UDF from the BRX Brightroll, I guess. And another important thing is that when you're actually dealing with HTTP, sometimes you want to extract the data from the response, especially if it's structured, and maybe do some follow-up requests. In our case, it is very important once we place a bit, we extract the information, and we want to make sure that all the pixels that we've generated for click, win notification actually are working. So the next natural step will be to extract them and then fire them. And then everything is declarative here. Another thing is that this represents HTTP request, right? But if I place the body here, it will have to be escaped and be very ugly, very difficult to read. So we also have this ability to delegate the data, like, we store the bits in one place and then HTTP requests in another place. So you can nicely expand, substitute this data, depending really on your needs. Okay. Let's talk what else. So once we started building this end-to-end testing for our system, we've seen one thing, that first and foremost, a simplified complex system, because now everything can run actually on your box, maybe on cloud, but you can orchestrate from your box, and you know all the components in and out. So debugging and troubleshooting is very simple. You can set one use case to be repeated when you initialize your system, and you can launch the debugger. You can step everything step by step. Another thing is you really focus on the input and output, because this is the way you communicate with the testing. You provide your input in form of data for various components, and you provide the output which your application and maybe other components produce. Another thing, we also using Endly to kind of set up environment. So I don't need to have Go installed. I don't need Java installed. I don't need to have anything installed. I just run Endly, and it just takes care and install everything for me on my box from scratch. Like historically, I remember when I joined companies, there was always this wiki, and the first week engineer is supposed to kind of, follow up this wiki, set up environment. No, this actually can be automated, and it could be instead of spending this time documenting wiki, you can spend this time to actually provide instruction to Endly and get these things automated. Another thing we actually realized that once you've got this production system replicated on our boxes, any defects that we see on production, we can really easily replicate on our boxes, because we've got a script that takes from production user data, metadata, and immediately provide the similar setup on our box, and we can step by step debug it, and we know immediately, within an hour, what's going on, why something doesn't work, without touching production. And finally, we also changed our deployment rules. We're not deploying, towards the end of the sprint or once a sprint. We're actually deploying every time someone believes it's ready, and this is one rule. Well, we need to pass end-to-end testing, and we need to have every single feature covered. And this enables us to pretty much be very rapid with the deployments. And there's no anxiety about deployments or something goes wrong. If it goes wrong, it means that either wasn't a review or something wasn't covered into end testing tool. And finally, I think this is a great opportunity to get QA team reviewed, be part of the review process, and then also contribute toward the testing. We primarily use this tool as an engineering tool during our day-to-day work when we deliver our product, and really this is where we're standing with this thing.